I'm going to multiply. That constant quantity is called as a common ratio. You see that this is a. I multiply this by R. I'll get AR. I'll multiply again this preceding element by R. I'll get the next element as AR square. I'll multiply AR square by R. I'll get AR cube. I think you are able to see this. A. When I multiply it, AR. This AR I'll multiply with again R. So what do I get it? AR square. This I will multiply. Okay, I'll do one thing. I'll write it here in order. A is there. First element A is there. I'm going to multiply with R. I'll get AR. Then this I'll multiply with R. I should not write equal. AR will take it. AR I'll multiply with R. AR square. AR square multiply with R. AR cube. See the number. This is a geometric progression. So this R is called as a common ratio. These are the elements. This yellow color are elements. Common ratio is this one. How to calculate the value of nth term, nth element, A r to power of n minus 1, where A is the first term, R is the common ratio, and then is the portion of element in the group of numbers. Now, what is the sum to n terms? What do you mean by sum to n terms? I'm going to add up here. I'll add up A plus AR square, that one. When we solve it, we'll end up this formula. A into 1 minus R to power of n by 1 minus R. What is the geometric mean between A and B? Under root of A by B. If there are, instead of n, if there are infinite terms are there, what is the sum given by A into 1 minus R, where R is less than 1? If R is greater than 1, you are going to write A into R minus 1 in the formula. Sum to infinite series. If they're finite, use this formula. If the elements are infinite, use this formula. Let me directly take the few questions. 1, 2, 4, 8, 16. These are the elements are there. So what is the pattern? We'll search it. Common ratio we'll find out. 1 into 2, 2. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. So what is the common ratio? Common ratio is 2. First element is 1. We'll write it here. This is the first term. This 2 is common ratio. And what is this? Number of terms. You count 1, 2, 3, 4, 5. Total number of elements 5. So what is the sum of all this? We'll use this formula. I'll get 31. Also, just adding up like this is not advisable. Adding like this not advisable, because only 5 elements are there. Okay. 5 elements are there. Okay. If there are some 30 or 50 or 150, 200 or 1000 elements, this is not advisable. Formula is advisable. This is sum to n terms. 5 terms are there. So 2 to the power of 5 will come. Then first term is 1. Common ratio 1 minus 2. Solving this, we'll get the required answer. Find the sum of first 10 terms of geometric progression. Okay, I do have this much only. I don't have further elements of the pattern. What to do? Well, the first term is what I know. This is the first time I know it. What is the common ratio? I think it will be 3, no, here. I'm showing it. 4 into 3, 12. 12 into 3, 36. 36 into 3, 108. So I know now this particular parameter. Then sum to n terms. I'll use this formula. First term is a number of terms, 10. Common ratio is 4. Okay, substitute all this here. We'll get the sum to n terms, sum to 10 terms. Is it advisable to add? If you have a patience, okay, go for it. 108 by 3, add number. Again, that number element will come again, multiply by 3. Like that up to 10 term. Then you add all that, you'll get this one. Or else use this formula. It's left to you. Okay, we'll discuss some two problems. I'll come to harmonic progression. Okay, now see what is the use of this? Like again, sir, geometric progression, is it of any use? Let me give you best example. I think we all will have a family. We'll have our family tree, ancestors, everything. Okay, let's start with our like if you could trace your family tree back for 15 generations, starting with your parents, how many ancestors would there be? So I'll do one thing. These are my parents. This is my mother, and there's a father. I'm from Karnataka, so we'll call mother as Amma. Mother, and I'll call her as, my father is called as Appa. Okay, now my grandfather. Again, grandmother, grandfather. Like this, shall we construct our? I'll construct my family tree. Of course, I do love my family. Okay, I'll keep on trace out all my ancestors, where they are, how they were, everything that one. What was the question? 15 generations. How many my ancestors are there? I just wanted to thank my ancestors for providing such a good family values. I just wanted to remember them. Okay, these many ancestors. Okay, I should really thank them because of their genetic things, their discipline in life, their sacrifice, their family values is what we are enjoying. We are leading certain happy life because of them. I just wanted to know my ancestors all. Okay, the formula is what? Let's do one thing. I think my parents are the first, no? So I'll start with them 2. Next, my grandparents will become 4. Great grandparents will become 8. Great grandparents will become 16. Next, 32, 64. Like that up to 15 generations. Okay, I'll keep on fill up this blanks. Finally, I'll end up till 15th. Then from there, I'll start adding sum of all the elements. I'll get my total number of ancestors. This is one method. Or else, can we use formula? Okay, first 2. The A is 2. The first term is what? 2 in the group of numbers. What is the common ratio? We check it. I think it's a 2, no? Set to that one. 2 into 2, 4. 4 to ja 8. 8 to ja 16. 16 to ja 32. So common ratio is 2 here. So I want 15 generations. So I'll substitute all these things. Solve it. I do get my ancestors. These many ancestors, 65,594. I think it's not a small number. Literally, we should thank all these many ancestors for what we had. And the God, of course. So you see, like, it's not that, say, the mass is something which the scientists observed in nature, they brought mass. So what we should do now, we should go back. So we should start rediscover things. We should go back to nature and, okay, where I'm studying this mass. Let me, I think there's a bacteria which will be widely used in the labs. There are initially, okay, there are like there were 3 bacteria in the culture initially. What would be the total count of bacteria at the end of the 6th hour? So it will initially how much it is? 3. After 1 hour, it will become 6. Then after 2-hour gap, they'll become 24. After 1 hour gap, they'll become 12. 6th hour is asking. 6th hour means you have to count from here. 1. This will be 1, 2, 3, 4, 5, 6. Okay, what is the total count? You have to add up all these bacteria. You get the total count. Or else go for geometric progression. The first term is 3. 6th hour means 7. You have to take it. N equal to 7. Then solve this. 2 to the power of 7 minus 1. Oh, sorry, some mistake happened here. It's 6. No, it is. Yeah. No. 2 to the power of 6 here. So we'll get this one. No? So what is the total number of bacteria? 189. I think widely used in the lab to confirm the whether